Hi, my name is Yuri, and in this video I'd like to share my experience of making wooden toys, how to turn drawing into the real object. Basic idea is to use CNC router to cut out the parts using double-sided machining, then finish and if necessary assemble parts manually. Usually the design starts from the idea. In this video I'm going to use the image of a car which was created by my sister. Looking at the image, it is nice to visualize how the toy should look like. What will be the components of the toy? Will it be a single piece or multiple pieces? What type of wood will be used? These questions are important to answer in the very beginning, as you can trace the picture more precisely and create vectors you really need. In case of this car, we decided to make more 3D looking model with standing out fenders. So there will be the following components: car body, fenders, wheels and axles. Next, what I usually do, I transfer a sketch into the vector form and use those vectors for toolpath generation. To do that, I drag the image into the Inkscape and using the Bezier tool in Spire mode, I trace the contour of the drawing and create vectors of the parts I need. I prefer to use layers. I usually keep my image on the first layer and create vectors on the layer above. In this case, I can reduce opacity of the image and see the track more clearly. Also, at this step, I can easily correct the design and add some extra features if necessary. For example, this little window is a bit too small, and if I'd like to machine it, it is going to be too thin in here. So, what I'm going to do is to shift both vectors a little bit to the left, making this window a bit larger. Also, I think it's a good idea to add a stoplight here, that the car would look more realistic. In order to draw the inner parts of the fenders, I'll use the contour of the wheels. The wheels themselves I'm going to construct in Cut 2D directly, where it is much easier to do. Alright, the vectors look good to me, and I think it's time to import them in Cut 2D and finish the design there. In Cut 2D, I split vectors into various components, which can be copied later in separate files. It will allow me to create specific toolpaths taking into account different stock thicknesses. So, I make another copy and separate fenders. Then I join the car body vectors and turn them into one continuous line that the tool can fluently follow at the time of machining. At the sharp corners, tools do not follow the actual toolpath, and depending on the tool diameter, there is always a bit of material left. In order to engraving look nice in cases like this, it is useful to prolong the engraving toolpath a little bit to ensure the desired component is separated. I usually split my design into different layers, so that I can select various parts and elements very easily later. Especially it is useful if you have complex design with multiple overlapping toolpaths. Let's add wheels to the design. As you can see, the fenders need to be corrected in order to follow the shape of the wheel. I create a rear wheel and then copy it to the front. Using circular vector creating tool, I add several circles which represent the wheel, the rim, and the fixation hole. Next, I copy the rim to the car body layer and join the vectors, making the reinforcement where the holes are located. Also, I create a new layer and move windows there. Front fender needs some final adjustments and the design is complete. So, when the design is finished, it's time to select materials for the project. In case of this car, we decided to use maple for the car body, mahogany for fenders, oak for wheels, and ash for axles. Also, I like to add little washers made of 1.5 mm plywood between wheels and the car body, so that they create a little gap, which makes a car model look more realistic. Now it's time to set the thicknesses of the parts. I have some wooden stock, so I choose the blanks based on what I have. It is going to be 30 mm for car body, 8 mm for fenders and wheels, and 20 mm for axles. And here is the tricky part begins. In order to make axles strong, the wood fibers should be aligned along the axle. To prepare the wood accordingly, I take a thick block of ash and cut the blank 90 degrees to grain, so that the fibers are going vertically along the axis during the machining. Also, I have very good experience of making wooden pins, axles and balls out of ash. This type of wood is quite strong and can be polished to a very nice silky finish. It helps to reduce friction and allow wheels to turn with lower resistance. Next step is to split design into different files according to materials used. It means that for this car I'm going to make car body, fenders, wheels, axles and washers in different files. The reason for that is the stock thickness, which is different for all those parts. Now I'd like to explain the method of double-side machining I use in order to avoid supports. The benefit of doing so is a possibility to have the part almost ready and finished right from your CNC. For example, this axle bolt is straight from the machine, no extra finishing was applied. Another example is an extra smooth finish of a cut surface, which is very important if it is visible side of your project, like contour of the car body. There is no visible marks of tooling and there is no need to remove supports and sand the whole contour manually. My method is based on the method of stock fixation that I found in one of the videos from Crimson Guitars. Link for that video is in the description. So, the idea is to use a masking tape and super glue. After applying tape on the table and your stock, you glue them together using super glue. Also, activator or simply water helps a lot to speed up the fixation. In this case, we get a very strong fixation in X and Y axis with possibility to pull the part in Z axis and detach it after the machining is done. Using this idea, I could cut out those tiny axles without any supports, only masking tape and super glue. Of course, to flip your stock over, you need to add dowels as markers to make sure that the bottom side will be aligned with the top side perfectly. Okay, here's an example of how to make toolpaths for a car body using masking tape method. So, after the stock is fixed, first CNC job I prefer to run is engraving. I tend to use two paths with different feed rates, which makes path very clean. As I fill them later with paint, it is important that the sides and edges of the engraved paths are smooth and free from any residual chips. It will ensure that paint stays inside the path without penetrating much to the sides or along the wood fibers. More details on this later. Next CNC job is roughen path of a contour and windows. While machining the windows, it is nice to remove material completely to prevent any breakage after the part is flipped over. It is critical for pockets which can have very tiny middle part left after the machining, so I prefer to use pocket tooling here. Also, I set the depth of cut not all the way through, but leave around 1 mm, which makes possible to flip over all the components together. After roughen path is done, I do finishing path with the same tool, but with increased RPM and reduced feed rate, for the whole depth in one go. It removes the lines left on the part from the roughen path and makes it 0.2 mm smaller, which helps to cover the flip over misalignment. Last path is going to be my round over bit. Here I use the one with 4 mm radius flutes. After the stock is flipped and aligned, I run engraving toolpaths for the other side. In general, I prefer to run all the needed CNC jobs before separating the parts. It ensures that each part is fixed while it is machined, as some of them can be very small and easily be detached due to impact of the tool. As a finish path, I run the round over job again, which separates the parts and makes the edges round. Here you have it, almost finished car body. The same idea applies to fenders and wheels, with slight variations due to specifics of the parts. However, I'd like to walk you through the machining of the axles, as it is a bit more tricky. First thing to do is to be sure that the block you work with has flat surfaces, that all the axles will stick to the tape and to the table as well. I normally use 20 mm end mill for planing this little stock in order to meet the requirement. Then I start to machine the side with axle's head and make a cut a little deeper than the axle head desired thickness. Also I finish this side with round over bit. After the stock is flipped over, it is very easy to cut out the axles, making a cut to the depth which intersects with the previous cut from the other side. It also eliminates imperfections in flip-over alignment. A little trick here is to leave 0.5 to 1 mm before going through. In this case, the impact of the tool will be minimized and the axle will stay in place after separation. Now you can see the parts of the car straight from the machine. All of them look very clean to me and have very smooth surfaces. It helps a lot for finishing them later using sandpaper. I really like the idea to finish our projects manually using sandpaper of different grades and painting the engravings, which add a human touch to the final product. In order to have engravings smoothly filled with paint, I apply liquid beeswax first to those paths which I'd like to paint. It seals all the cracks and fibers and prevents the paint penetrate there. Otherwise you can get the lines like this. They don't look very nice if you look closer. So after beeswax is dried, I add paint to those paths and wait before paint dries too. It is not a problem if you have a bit of paint outside the path. It will be removed at the next step during sanding. I tend to use 180 grit sandpaper first and finish with 240 grit. I find wood surface to be very smooth after 240 grit, so I do not go finer. After sanding is done, I use vacuum cleaner to clean the parts and make them ready for applying beeswax. But before, I'd like to take time and paint headlights and stoplights. After paint is dried, it's time for applying the wax. I use liquid beeswax, which is certified to be used for wooden toys. After the first layer is dried, I clean the parts with knife and fine sandpaper and apply second layer. Later I use fine sandpaper again, together with buffing wheel, which makes parts very smooth and shiny. Another benefit of using this wax is that the wheels turn much easier on the buffed axle due to more polished surfaces and as a result with reduced friction. After buffing is complete, it's time to assemble parts together. I use regular PVA glue for wood to do that. In order to have wheels turning freely, I add an extra cardboard spacers at the time of gluing. After removing them, the wheels get an extra space and turn very smoothly. So here you have it, a wooden toy made with the CNC router using double-side machining. After I discovered and practiced this method of machining, it became my go-to method for making almost all 2.5D and 3D projects using various materials. If you have any further questions, feel free to ask me. Hope in this video you have found some useful tips for your projects. Thanks for watching. Goodbye.